Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty, and today we will discuss about the simple air evaporative cooling system for aircrafts. So as far as the simple air evaporative cooling system for aircrafts is concerned, it is a modification of the simple air cooling system, and you do have all the components which are part of the simple air cooling system, but one additional component, that is evaporator, is added to improve the performance of the system. So the essential components of the refrigeration system is first your diffuser, then you have compression, then you do have heat exchanger, you do have evaporator, you do have cooling turbine, and you do have cooling air fan. The gas turbine cycle, which is a must for any aircraft, you do have a gas turbine and you do have a combustion chamber. Now, we'll discuss how actually the system works. While discussing the simple air cooling system itself, I have told you that this cycle cannot be discussed in isolation, because the gas turbine cycle is very important and the gas turbine cycle is required to run the aircraft. So how the different fluids flow and how the refrigeration takes place, we'll discuss in detail. So first of all, ambient air passes through the diffuser, and diffuser is a smoothly varying section which converts the kinetic energy into pressure energy. And the air after passing through the diffuser is known as ram air, whose pressure is higher than the ambient air. Then it is taken to the compression. In the compression, it is compressed, and due to compression, its pressure and temperature is significantly raised. Then, out of the compressed air, some person enters the gas turbine after passing through the combustion chamber. In the combustion chamber, heat and fuel is added. As a result, there is significant increase in temperature of the gas so formed, as well as its pressure. This actually expands in the gas turbine, and this actually produces the necessary power output to run the aircraft. And a part of the compressed air is actually made to pass through the heat exchanger. And in the heat exchanger, you do have a part of ram air which actually cools the compressed air coming from the compression, because the temperature of the air coming from the compression will definitely be higher than the ram air. So here the ram air produces actually the cooling. That means it cools the air that is coming from the compression. Then you do have a component which is known as your evaporator. And the function of evaporator in simple air evaporating cooling system is to produce additional cooling. Low boiling point fluids like ammonia, alcohol, or even water is used. And the evaporation of such low boiling point liquids cools the air further. And then this air enters the cooling turbine. In the cooling turbine, it expands, and the power that is developed is used to operate the cooling fan. The cooling fan actually helps in drawing air from the heat exchanger, and the air then enters the cabin or cockpit after passing through the heat exchanger and evaporator, its temperature is significantly reduced. So when it enters the cabin or cockpit, it actually receives heat from the medium to be cooled, thereby producing the desired cooling or refrigerating effect. Now we'll discuss the processes with the help of temperature entropy diagram. So you do have processes 1, 2, 2, 3, 3, 4, 4, 5, 5, 6 and 6, 7. So what are these processes? Before discussing the processes, we should know that there are 4 operating pressure conditions. You do have ambient pressure, you do have cabin pressure, you have ram pressure and you have a compression pressure. 1, 2 actually represents the process that is taking place in the diffuser, and this compression is what we call your ram compression. And in ram compression, the pressure of the air is increased, but no work is done upon the system to compress it. Due to shape of the diffuser, the compression actually takes place. 2, 3 represents the compression that is taking place in the compression. We may call it main compression also, but here you need to spend some amount of work in compressing the air. Then 3, 4 and 4, 5 represents 2 cooling processes. 3, 4 actually represents the cooling that is taking place in the heat exchanger, and 4, 5 represents the cooling that is taking place in the evaporator. As far as the cooling that is taking place in the heat exchanger is concerned, the ram air actually produces the cooling because its temperature is lower than the temperature of air coming from the compression. As a result, heat transfer will take place from the air that is coming from the compressor to the ram air, and here the cooling takes place due to evaporation or vaporization of the low boiling point liquid. As a result, the air will be further cooled. 5, 6 actually represents the expansion process which is taking place in the cooling turbine, and 6, 7 actually represents the refrigeration which is taking place in the cabin or cockpit, where it will actually receive heat from the space to be cooled. Now, as far as the coefficient of performance is concerned, all of us know that the coefficient of performance COP is equal to the refrigerating effect divided by the work done. Now, as far as the refrigerating effect is concerned, if the mass of air is represented, that is the mass of air that is actually drawn from this compression, you can call it MB, because we call it bled air. This portion of air is not sent to the combustion chamber, rather it is brought to the heat exchanger for cooling purpose. You may denote this as MB into specific heat at constant pressure multiplied by the temperature difference. The temperature difference is T7 minus T6, because the air entering the cabin or cockpit at 6 and it leaving at 7. Similarly, as far as the work done is concerned, work done will be equal to mass of the bled air multiplied by specific heat at constant pressure multiplied by the temperature difference. The air actually enters the compressor at 2 and it leaves at 3. So this is T3 minus T2. Now, the COP of the system would be the ratio between the two, that is nothing but T7 minus T6 divided by T3 minus T2. So for our convenience, we have considered all the processes to be isentropic processes. In actual case, the processes actually do take place with some increase in entropy. When this happens, there will be corresponding changes in the points. So 2 will become 2 dash, 3 will become 3 dash. Similarly, when you are considering the expansion also, it will not be 5, 6, rather it will be 5, 6 dash. So accordingly, you have to make modifications both in the refrigerating effect as well as the work done. So it will not be T6, rather it will be T6 dash. Similarly, it will be 3 dash, and this will be T2 dash. Now, after this lecture, I sincerely believe that your concept about the simple air evaporating cooling system for aircrafts would be crystal clear. But if you have any doubt related to this, please do put questions so that I will try to answer. Thank you very much for watching this video. I would request you to subscribe to my educational channel Erudispace if you have not done so till now. I would further request you to share this video with your friends and relatives to improve its visibility. Hope to see you soon for another lecture on my YouTube channel Erudispace.